انت حفظت في كده. تدرس الان احسن تدرس الميجر في الرحمه. فهي الافضل لكم. طيب بسم الله والصلاه والسلام. So last time we start talking about the conditional distribution and density. And the concept was when we derive the conditional inequality of density, if the density function is a surface like this, if this is the two-dimensional density function, then we will condition. For example, if we want to find the PDF of y given x equals specific value, then as if we are taking a snapshot at this value of x. So at this value of x, what will the PDF of y look like? How will be the total quality of 1 distributed among the different values of 1? Okay. Similarly, when we try to find the PDF of x given y equals specific number. So this is as if like you are taking a snapshot when y equals this specific value of 1. So how will the PDF of x looks like when y equals this value? Okay. And طبعا قلنا في ال continuous domain or examples it's a little bit always difficult to find. However, in discrete was much easier to visualize and find, and we took several examples of this. And then that was the conditional PDF and CDF when we have point conditioning, or we are conditioning at a specific value of x or y. However, when we have interval conditioning, we were able to derive the conditional PDF given y, for example, conditional CDF of x given y equal to in a specific range, specific interval. And this is why we call it interval conditioning. And we did this by using the original definition of the CDF, which is the probability that x is less than specific value, intersect with the condition, which is y between two values, y a and y b, divided by the probability of y a. Now the rest is just integrating the joint PDF between these two values and integrating the marginal PDF of y between y a and y b. And we end up with basically this result, or when we differentiate, we end up with this result. So we stop here. So today, inshallah, we'll take more examples, and then we'll talk about what we call statistical equivalence between two arguments. So the conditional, when we have interval conditioning, so for example, we have here, given the joint density function as this. This is the joint density function, the same example that we did last time. We did that last time in the example. We found the marginal PDF of x, marginal PDF of y, and we found the conditional PDF of x given y, the point condition, and the PDF of y given x. So today, we'll use the same example to find PDF of x given y in a specific range, not y equal to y, a specific number. So this is now interval conditioning. In order to find this, we use the rule that we derived above, where we find this by integrating the one PDF on the range of the condition divided by the integral of the margin of y over this range. Okay. Now this range is y less than or equal specific y. So this should be from minus infinity to y, right? However, we have the PDF is only defined at 0 only for positive y. And because of that, we need to differentiate. We integrate, of course, the joint PDF from minus infinity to y. However, when we express the PDF, we need to integrate only from 0 to 1, because minus infinity to 0, the value of the PDF is okay. And since we are integrating this with respect for x minus infinity to infinity, so this gives you basically this whole thing gives you fy, so gives you PDF of y, right? PDF of this the integral with respect to x, and you want to integrate from minus infinity to y, which gives you the CDF of y evaluated at this value. The rest is just math. You need to integrate the joint PDF with respect to x to y from minus infinity to y. So So this is it basically. You just plug here the joint PDF, which is x e to minus xy plus 1. So this is it. This is the joint PDF. And you integrate with respect to y from minus infinity from 0. And since this is an integral with respect to y, everything with respect to x is real. Take it outside. So everything with respect to x is x e to minus x, right? And we end up with, so x to minus x goes outside, which as here, u of x e to minus x. And we end up with e to minus x y plus 1. So basically, e to minus xy is what you want to integrate. So what you get as integral is 1 over x minus x e to minus y. Minus it. When you plug 0 to y, you get this. And this is only valid for y double. So I just send 0, what is the answer here? 0. The PDF of x given y less than 0 is 0. Yes, there is no probability. It's impossible. Okay? And fy of y is simply you integrate the marginal PDF of y, which we found last time. We found it last time from if you go up in the slides. And integrating this, you will get basically this. So now the answer is this divided by this. The answer will look like the PDF of y given y less than or equal specific value will be the two values that we one over the other. You get basically this expression. Okay. Or you can just remove the u of x and write it with y. Either you write u of y or y number. You remove u of y. The u of y means y. This is valid for y. Now, if you plot this, just to visualize what is happening. Now, we are plotting here fx of x given y less than specific value. So we are plotting first of all y for the value of y equal infinity. What does this mean? We are finding the PDF of x given y less than infinity. That's my initial condition. No, basically it's not infinity because y less than infinity is a certain event. I know that. So as if I am conditioning on a certain event, I can say, as if there is no condition. The sample space is not changed. If I condition, the condition is a certain, as if it's not, right? So fx of y of x given y less than infinity is the same as fx of x, which is the margin of x. So because given y less than infinity is a certain event, doesn't change anything about this. I know always that y less than. So if the PDF of x doesn't change. And if I change the value of y, which is the condition, basically you can see that the curve of the PDF of x changes. So this is, for example, y equal 10, y equal 1, y equal 0.1, y equal 0, for example. Okay. Are you sure? Any question? So you should be able now to find the conditional PDF with false condition or invalid condition. Any question about the y equal infinity? So, and what are we plotting is this PDF. This PDF. PDF of x, so it's a function of x. So this is a PDF of x given y less than a specific number. This is plotted for different y's. So y equal infinity, ايش معناها? We are plotting PDF of x given y less than infinity. We know that y is always less than infinity. So this is as if we are plotting PDF of x. Here expression, we'll find it for another. And then changing y, you can see that it becomes, for example, y equal to 10, which is a large number. It looks like closer to fx, which is the margin. Now, when y becomes smaller and smaller, PDF of x becomes a little bit or more and more different than the original PDF of x, because the condition becomes smaller and smaller and smaller. Any question? Right. So basically, by this, we end the concept of the joint PDF, conditional PDF, marginal PDF. We talked about it for continuous value variables, discrete value variables. We have several examples. So please, we are trying to do all of these concepts because they will accumulate and it will be extremely difficult later to get them together. What is next in the class is the discussion about statistical independence. Do you remember what this was? When we discussed independence. Chapter 1, لما كنا نتكلم عن independent events. When we say that independent events A and B are events that are what independent events can? So, basically the probability of the intersection between the two events equals the probability. And this comes from where? How did we get this? Yeah, basically, when A happens, so the probability of B given A equals so basically, the happening of A does not change the probability of B. And from here, we were able to derive the probability of the intersection between A and B equals the product of the two. So independent events, two independent events, A and B are independent events if probability of A given B equals probability of A. So basically, the happening of B does not change the probability of A, and vice versa. Which, if we like this leads to probability of A intersect B equals the probability. Now, similarly, there in chapter 1, we will talk about events. Events means that we run an experiment, like I'm running a dice, and we basically try to examine event A of all numbers, event B is number 2, and then try to find what is the probability of A given B, whether they are independent. Okay? Now here, we'll talk about it in terms of random variables. So the same concept, the same understanding, however, in terms of random variables. We say that two random variables, X and Y, are independent if what? If similar to A and B. However, here A will be the event that X is this number, will be the event that Y is this number. So this will be like A, and this will be like B. Now, X and Y are independent if the joint probability of X is a number and Y is a number equals the product of probability that X is a number and the product multiplied by the probability that Y is. And in terms of probability, نفس اللي تكلمنا عنه هنا ثابت here. But what is this? By definition, ايش سميناها؟ By definition, the probability that X less than X, small x, and Y less than small y equals the CDF of X and Y at X and Y. So, what is this? CDF of X. What is this? So, two random variables X and Y are independent if the joint CDF equals the product of the marginal CDFs. Okay? So the joint CDF can be decomposed. Okay? يعني لو تشوف مثلا السي دي اف اللي هنا او البي دي اف اللي هنا، خلينا نكمل على البي دي اف بعدين نرجع. Now if you differentiate this with respect to x and y, you will find that the PDF of x and y, the joint PDF, equals the product of the margins. The product of the margins. What does this mean? It means that the PDF of x, the joint PDF, can be written in terms of two functions, decomposed. One function with respect to x and another function with respect to y, decomposed. If you go back to the last example here, كيف كان البي دي اف شكلها؟ ux, uy, which means that x starts at 0, y starts at 0. However, x e to minus xy plus 1. Can this be decomposed in terms of two functions, one with respect to x and another with respect to y? لا، ليش؟ في بينهم هذا x و y داخلين في بعض. You cannot decompose. Okay? And because of that, we will show in a minute that these two random values, x and y, are not independent. Simply join PDF, that's the part. You cannot decompose. Right, this is in terms of math. What does it mean in terms of physical meaning? What does independent mean? Two random values are independent. Means what? في الإيفنتس واضحة كانت. If one happens, كان لا يتغير. الطريقة حق الثانية is the same. So if A happens, if B happens, the quality of A does not change. The quality of A given B is the same as for B. هذا سهل في الإيفنت. What about for random values? What does it mean that X and Y are independent? X and Y are independent means that the way X behaves has nothing to do with the way Y behaves. يعني إذا الآن نشوف مثلا خلينا نقول خلينا ناخذ two different examples. خلينا نتكلم عن الويذر. اوكي، الويذر in terms of temperature and pressure. وبعدين نتكلم عن الويذر in terms of temperature وشيء ثاني. خلينا ناخذ. الآن الويذر in terms of X represent the temperature, Y represent the pressure. أو the humidity. ايش رايكم؟ الآن ناخذ بعض ولا؟ ما لهم علاقة. هم they are basically both of them they will define for you what the weather is. Okay? وعادة التمبريتشر والبريشر لهم علاقة ببعض. Basically when the pressure becomes high, usually the temperature ممكن تزيد أو تنقص، مرات when the pressure يقل يصير في رطوبة عالية. So basically they are interconnected, physically point of view. Forget about physically. Because they are physically connected, the random variables that represent the pressure and temperature are related, are connected. لهم علاقة ببعض. تغير واحد يغير الثاني. واضح؟ الآن خلينا نتكلم على same example weather. However, let's take X as the temperature and Y as the هلال على مصر. يعني أول شيء two are random values. The temperature is random variable. نتيجة الهلال والنصر is another random variable. صح ولا لا؟ It could one factor. يا الهلال يفوز يا النصر يفوز. واحد منهم كذا جول. صح ولا لا؟ ففي distribution معين على الواي اللي هو الفوز المباراة الهلال نتيجة الهلال والنصر مثلا. اوكي؟ So الآن you can see physically الويذر ما له علاقة بنتيجة المباراة. صح ولا لا؟ تمام ما له علاقة. شيء يعني physically ما شيء ما له علاقة بشيء. These are two random variables that are independent. نتكلم عن physical point of view. الماث واضح. لكن physics point of view it's always important to understand what does this mean physically. مو بس تفهم المسائل لازم تفهم ايش معناها. So when two random variables behave independently ما لهم علاقة ببعض، ما في أي علاقة تربطهم، then these two random variables are called independent. And when they are independent, the joint CDFs become decomposed, can be decomposed into two separate functions for X and Y, and hence the joint PDF can be decomposed into the marginal PDF, separate functions in X and Y. الآن إذا هذول two random values لهم علاقة ببعض physically هتلاقي إنه this cannot be decomposed. They are connected. Okay? مثل الإكزامبل. واضح شباب physical meaning؟ Okay? نفس ال A وال B لهم علاقة ببعض ولا ما لهم علاقة ببعض. بس هنا ما نتكلم عن two events only، نتكلم عن random values. كل random variable represent a variable in the weather, in the traffic، مثلا الجريدز حقت الطلاب، مثلا الويذر والجريدز حقت الطلاب لها علاقة ببعض. هذا random variable X، هذا random variable Y. temperature برا والاختبار نتيجة اختباركم في major one. X and Y are they independent or dependent؟ ايش رايكم؟ ما علاقة ببعض، الوضع حر ولا يعني اخذت المادة في الحر ولا في البرد حتلاقي اخر شيء درجة لها علاقة ب your understanding وصعوبة الاختبار. Many factors that has nothing to do with the weather and so on. So you can now at least imagine different examples and different scenarios where you can have dependent random values or independent. بينما مثلا الآن your results in exam 1 and the level of difficulty of the exam. X is your results and Y is the level of difficulty. خلينا نقول level of difficulty can be a random variable from 0 to from 1 to 5. ايش رايكم؟ لهم علاقة ولا لا؟ they are dependent. لهم علاقة قوية. إذا الليفل اوكي الطلاب ممتازين، لكن إذا الليفل صعب تلاقي آخر شيء الجريدز شوية منخفضة. إذا الليفل سهل تلاقي الجريدز مرتفعة. So these are kind of examples of dependent and independent variables. Now, here comes a conclusion from these two. So let me say it this way. From here, we can conclude similarly to what we did here. If the joint PDF can be decomposed into the marginals, then we can write the PDF of X given Y less than a specific number as نرجع للدefinition. What is this? This is equal to the probability that X less than or equals 4X, right? And intersect with Y less than specific Y divided by the condition, probability of the condition. But now, because they are independent, you can decompose this. Sorry, you can write this as the joint PDF. And then, because they are independent, you can decompose them into the margin. And now, the margin of Y cancels the margin of Y, and you end up with the CDF. So if they are independent, then the CDF of X given Y less than a number equals the CDF of X. نفس الفكرة هنا. The probability of A given B equals the probability of A. So the conditional CDF equals the marginal CDF. Similarly, if you flip X and Y. Now, if you differentiate, if you now go to the point conditioning also, and try to find the probability, the PDF of Y given X. Now, we have found that this is the joint PDF divided by the marginal PDF of X. However, because they are independent, the joint becomes the product of the margins. Now, the PDF of X cancels the PDF of X, and we get the PDF. So the PDF of Y given X equals the PDF of Y when they are independent. X and Y are. Right? Similar to exactly similar to what we did for events. However, here we extended it for random values X. أي سؤال يا شباب؟ Let's have several examples. Here I'm giving you the PDF that we have used before in different examples. Now, are X and Y independent? So if I ask you this, what do you need to do? You find the margins. You don't decompose the margins. You cannot decompose this. Can you decompose this? It's not exactly. How do you know that you can decompose? مو كل الفانكشنز ترى exponential إلا تضربها ببعض. مرات تكون شوي معقدة. What is the safest way to do it? Find the margins and check if you multiply the marginals, will you get the joint PDF? That's the way you do it. So when I ask you, are they independent? You need to find the PDF of X. And you need to find the PDF of Y. Again, we did it before. We have not repeated it. It's there in the slides before. And check is fx of x multiplied by fy of y equal or not equal the joint PDF. And you can see that clearly. هنا في عندك fraction exponential هنا ما في fraction. So if you multiply this fy with fy of x fixed, clearly you will never get the joint PDF. And because of that, they are not independent. Not independent. Okay? أي سؤال. Another example. Are they independent? وأنا أعطيك الجوين PDF. طبعا هنا واضحة إنها they can be decomposed. واضح إنه هنا exponential منفصل عن الثاني. لكن زي ما قلنا مو دائما يطلع لك بالسهولة هذه. مرات تكون complicated expression. So in general, you need to find the marginal. How to find the marginal of x? What do we do? To find f(x) of x, what do I do? Integrate this joint with respect to y. So I integrate, in order to find this, I integrate with respect to y, the joint PDF. Now, when I integrate with respect to y, anything in x is a constant. So I end up with only one exponential, and I integrate from 0 to infinity, and I get this. In terms of PDF. Similarly, if I integrate with respect to y, so if I want to find PDF of y, the margin of y, I integrate with respect to x. The same function, the same joint PDF. Again, everything with this is integration with respect to x, anything for y is constant, it's outside, and you end up with this PDF. Now check. Multiplying this PDF with this PDF, will you get this one? Yeah, clearly you can see 1/3 multiplied by 1/4 is 1/12, and you have u of y, u of x, e to minus y over 3, e to minus x over 4. So clearly you can see that they are independent. Okay? So when we say independent again means that x and y behave independently. And physically, usually independent random variables usually represent different things, different environments, different variables that are not related. Now let's see, at least learn what we call the scatter plot, and then see what does it mean. Before we go into this, now if we have three random variables, x, y, and z, and we say that they are independent. In this case, first of all, they have to be, every one of them is independent. So x is independent of y is independent of z, x is independent of z, and the three of them satisfy the joint PDF of the three can be decomposed into the margin. So first of all, x and y independent, x and z independent, z and y independent, right? And this. So we have these conditions to say that three random variables are independent. So every pair are independent, every pair is independent, and the three of them are. Now, if they are independent, then any function of these become also independent. If I take a function of x, g of x, and the function of y and z, h of y and z, they will also behave independent. Now let's talk about the scatter plot. This is a very important concept. Now, what is scatter plot, first of all? Scatter plot is when I collect samples. So for example, let's take the weather sample, the weather example. So for example, when I measure the weather every day, what do? I measure temperature and pressure. Okay? Today I measure the temperature and pressure. I found that this is temperature equal كذا, but pressure equal كذا. So I just plot 1 point. Tomorrow I measure the temperature and the pressure. It will be another point. After that, I will measure. It will be another point. Every day I measure. So you can see how many points here? Many. 100, 200, whatever. These are the number of samples. Every time you measure, you put a point. What does the temperature was and what is the pressure value was. Okay? Now, repeating this for many samples, you end up with what we call scatter plot. Okay? واضح السؤال؟ ايش هذا البلوت؟ ايش معناه؟ I repeat. You take, every time you take measurements of two random variables, you put a point in the measurements. So this point means that you measure x equal كذا, y equal كذا. The temperature equal, will the pressure equal كذا. Next time you measure again, you get another point. So this is x equal كذا, y equal كذا, and so on. You repeat everything. So what you get is the collection of samples plotted against x and y. Okay? Now, looking at this scatter plot, you can know whether they are independent or not. لهم في علاقة بينهم ولا لا؟ الآن خليني أسألكم السؤال هذا. هنا scatter plot هذا، what do you think؟ في علاقة بينهم ولا لا؟ Why do you say this?
I say that it is positive, and as the x increases, also y increases.
Exactly. So you can see here that there is a trend. في واضح انه اوكي هو لخبط شوي لكن الترند واضح انه as x increases in general y increases. As x increases y increases. صح؟ Now, if you see a scatter plot like this, a data that is plotted like this, you know that they are independent. So you know that they are not independent, they are dependent. Because واضح في علاقة بين x و y. As x increases, y increases. Okay? Without knowing even the PDF or the joint PDF or the marginal PDF. But just looking at the data. Well, here you can see ايش رايكم هنا؟ Dependent, however, there is an opposite negative relationship. Negative dependence. You can see that the trend looks like this. As x increases, what happens to y? Decreases. On average طبعا نتكلم. في مرات يكون العكس، مرات يكون x هنا y يعني شوف مثلا هذه النقطة هذه out of the norm, out of the trend. هذه النقطة شوف x متوسطة لكن y مرة عالية. لكن in general most of these points lie within the trend. This is negative dependence. هذا سميناه positive dependence أو relationship أو بعدين نسميها correlation. What about here? What do you think? واضح انه ما في علاقه واضحه. ممكن يكون في علاقه لكن اتليست من السكاتر بلوك هذا واضح انه الواضح لنا انه ما في شيء. ما في behavior واضح. اتليست هذا الشيء بسيط يعني طبعا هنا احنا we did not plot the PDF, we did not plot the joint PDF, we didn't know anything about these detailed functions. لكن what we know is just data plotted against x and y. Here you can see that it looks circular. ما في trend واضح. So we don't know. Like in general, things of that sort, usually they are independent or at least uncorrelated. We tell them again at chapter 5, what there's a weaker form of independence, uncorrelated. So at least because there's no clear trend, we think about these as independent numbers.
عندك 65 اندكس عندك 170 في الواي ايضا كل ما ابتعدت منها كل ما ابتعدت الاكس تبتعد في الواي.
لا بس انت لو تلاحظ هي تقريبا سيمتريك كل ما ابتعدت بالاكس ابتعدت بالواي both ways بكل الاتجاهات لكن هذا صحيح يعني ابتعدت بالاكس نيجاتيف تبتعد بالواي نيجاتيف اذا ابتعدت بالاكس بوزيتيف تبتعد بالواي بوزيتيف او نيجاتيف صحيح في كل الاتجاهات صح؟ لا هو هنا شوف انت هنا you can see clearly that تقريبا the average of the data in the x is around 65 والaverage of the data in the y is around this point هذا الافريج لكن الداتا لما تشوفها ما في ترند واضح انه لما x يزيد y تزيد ولا تقل ما في اي واضح انه ما في علاقه بينهم كل واحد ماشي لوحده يعني في داتا تلاقيها يعني مثلا هنا هتلاقي ربع الداتا x مرتفعه y منخفضه ربع الداتا الثانيه x مرتفعه y مرتفعه ربع الداتا الثالثه x منخفضه y مرتفعه والربع الرابع y مرتفع y منخفض في كل لاين فما في اي ترند يقول انه والله لما x يزيد y تزيد ولا العكس they look like it doesn't matter x تزيد ولا تنقص y تزيد وتنقص independent واضح السؤال الفكره؟ مهم جدا again you connect الماث مع الفيزيكس physical meaning Any question? We leave this now and go to another subject. So, any question about independence, شباب؟ المعنى الفيزيكال Now, let's talk about the distribution and density of a sum of random values. If we add two random values that are independent, x and y, and we are interested in the PDF of the sum. So here we are not talking about the joint PDF of x and y. No, we talk about w, a new random variable, equals x plus 1, where x and y are independent. Why is this important? This problem is important because in many cases, electrical engineering and other fields, you are interested in a signal that is addition of two signals. For example, your signal and a noise communication. And there's no reason to believe that the noise is related to your signal. عادة النويز ما نعرف السيجنال، النويز يطلع دائما. السيجنال تكون AM ولا FM ما تفرق. السيجنال مرتفع ولا منخفض النويز موجود. So usually there's no reason to believe that your signal and the noise are related. And because of that, they are related. And we are interested in the received signal, which is the noisy signal. And then in this case, we are interested in finding the joint PDF. Sorry, the PDF of the received signal, which is W. Okay? Well, this is one example. So in order to find it, again, we go always back to the definition. So we start usually with the CDF. مثل ما سوينا لما اتكلمنا عن function defining value. When we say y equal g of x, and we were interested in finding the CDF of y. ايش سوينا؟ If you remember, y equal g of x, and we wanted to find the PDF of y. تتذكر ايش سوينا؟ قلنا PDF of y ايش بقى؟ What did we do? في قانون نهائي طلعناه مع بعض. What did we do to find it? هذه هي أهم شيء. Yeah, f of y. How do you find it? أول step إيش كان شباب؟ Use definition. What is f of y? What is this CDF? What is it? Probability?
Y.
Y. Less than or equal? Small. لا small y. بعد كده نعوض في الواي. ايش الواي كانت؟ g of x. Less than or equal to y. And then we ended up with probability that y, sorry, x less than or equal g inverse of y. Right? And then we differentiated this and we found the CDF function. Similarly, we start with the definition of CDF. What is the definition of the CDF? What is FW of W? Is this? It's the probability that W is less than a number. W is less than a number. What is this number? Is a small w. Okay? And what is W? X plus Y. Exactly. So this is the probability that X plus Y is less than a specific number W. Now, we know that the probability that of any event is the integral of the joint PDF over the limits of this event, right? The x, y that correspond to this event. So we need to find the limits for this event. What is this equal to? This is probability that مثلا خلينا نقول y or x less than or equal what? W minus y, صح? So if we plot a line which is x equal w minus y, or the line which is x plus y equal w. What is this line? It will look like this. X plus y less than w. This is the line x plus y equal w. Then we will integrate with respect to what? All the regions, for the region that x plus y is less than or equal w. So which region is that? Is it above the line or below the line? Below, right? It's x plus y less than or equal to w. So everything that is below this line. So the integral, the region of integration is the region below the line. What are the limits for this region? Is this 315 or the calculus line? Calculus has nothing to do with 315. So what is the region of integral? Yeah, what is the region of integration? This is the integral of the joint PDF. But what is the region of integral? It's x plus y minus w. So you can have it as from minus, with respect to x, for example, you can have the integral from minus infinity up to this point. But what is this point? Nice, what is this point? X equals w minus 1, right? This is the line. So you integrate x from minus infinity to w minus y, and then you integrate y with respect to what? The whole thing. Minus infinity. So x will be sliding from minus infinity up to w minus y, while y will go from minus infinity. But this is the way we find the region of integration. Do you have any question about how did we find this? Now, if you are convinced, and we know that they are independent, right? احنا بدأنا قلنا the problem is two random variables x and y are independent. So what is the joint PDF? It's the marginals multiplied by each other, صح? The marginal PDF of x multiplied by the marginal PDF of y. So I have an integral here, which is the marginals. Now, if I integrate with respect to x, يعني نرجع الانتجرال هذا. With respect to x, dx, what do you get me? What does it get me? I am integrating fx of x from minus infinity to a number. What is this equal to by definition? The CDF, exactly. Evaluated at this number. The CDF of x evaluated at w minus 1. Huh? Multiplied by the PDF of y. So PDF of y as is. So now I have the CDF of w at w equals the integral of the CDF of x evaluated at w minus y multiplied by the PDF. Now let's find the PDF of w. In order to find the PDF of w, what do I find? What do I do? What is the PDF of w? Derivative. I differentiate. This one, I get the derivative, the PDF of w. I differentiate this. And now if I differentiate this, what do I have? I'm differentiating with respect to w. Where is w here? In this integral. And so integration is just a summation. So don't be scared when you differentiate a summation. When I differentiate this, I'm differentiating a summation of this function. Where is w here? In the CDF. So here has nothing to do with w. So when I basically differentiating a summation of this function with multiplied by another function, the function هذا بالنسبة للدifferentiation is what? Constant, صح? ينزل مثل ما هو. So what I will differentiate is the function that I'm differentiating with respect to, which is this. Differentiating this give me what? The PDF evaluated at. So differentiating this will give you the PDF evaluated at the same number. And fy of y will come as this. What is this? Where did you find? Where did you see this before? What did you call it? Convolution. That's what we خلصته منها. Okay? Now possibility قبل اسماعيل درسنا شيء طلع فيه convolution يعني wherever you go you'll find it. Anyway, so this is the convolution of the PDF of y convolved with the PDF of x, both of them evaluated at the b. So the PDF of w equals the PDF of y convolved with the PDF of x. Okay? Now, quick example, the simplest example. So how did we find this? Basically, the first part is to integrate the joint PDF over this region, x plus y less than or equal to w. We found the region, the limits of the region, and then we ended up using the independence, and then we differentiate. Now, let's have the simplest example that you can have about convolution, which is when you have two uniform random variables. So x here is a uniform random variable from 0 to a, and y is another uniform from 0 to b. So both of them are uniform. Random values that are independent. ممكن واحد منهم representing the phase of the received signal, الثاني representing the I don't know, the noise. The phase of the received signal has okay. Then in this case, you need to find the PDF of W, which is equal to X plus Y. And again, X and Y are independent. So basically independent means that the P. الآن لو أعطيتك سؤال زي كده قلت لك find the PDF of X, Y. Can you find it? No. What is this that I was not here? What do we call it? What do you call this thing? The joint PDF. What is a joint PDF? Independent, integrating. Independent. What does independent tell me? This is equal to the two PDFs that you see here. ليش؟ لأن أنا قلت لك إنهم إيش؟ independent. ميز يا شباب بين هذا وبين هذا. What is this? Is this a joint PDF? No, this is a PDF of one random variable. هذه joint PDF of two random variables. هذه مو ما لها علاقة بهذه. لأن هذا خطأ شائع. أول ما تكلمت قلت convolution. Convolution of what? This equal what? يا شباب. What is this equal to? Convolution. This is the convolution. This is the convolution. The PDF of the sum. This is the sum. Okay, of X and Y. This is a random variable, which is the sum. So W is a random variable. But you need to distinguish between these two things. هذا product, هذا convolution. لا تحفظوه، لازم تكون فاهمين ايش معنى كل واحد. شكرا جزيلا. شباب تصير شغل. سندي لكن distinguish please. Thank you.
ممكن نخلي يفرض الأحد؟
ايه قلنا الأحد تجيب نفسك؟ سيدنا